Hello, AP Stats. How we doing today? This is summer session number 1. Hope you're having a fantastic summer, and we're ready to get it going here. And again, hope vacations are well. Hope everything's going good. We're going to get started with some of our summer sessions here. These are supposed to be fairly quick, not too in-depth in terms of your statistics knowledge, but you're going to find out that as we go through it, a lot of this stuff you already know. So it's kind of an introduction into the course. We're going to talk about why I'm holding this holy grail right here. We're going to talk about that. And we're going to also talk about just some logistics on AP statistics. So glad to have you. Glad to have you join us. Let's get it underway, and let's rock and roll. All right. The first thing I want to mention to you, hopefully you've got your notebook out. You can take some notes here in terms of section 1.1. As we go through this, we're going to hopefully hit this fairly quickly. And so your job is to take notes. And as you do it, then go ahead and do the quizzes that are associated to sections 1.1, 1.2, and 1.3. All right, with that being said, let's get it started. Section 1.1, we're going to talk about, we have this randomly selected study that we're doing. And as you look and as you see in AP statistics, we're going to talk a lot about terminology. And so we're just laying the groundwork for what are these specific terminologies and what do they mean. First thing, we recognize that we have 10 randomly selected U.S. residents. So as we look at this, each resident comes from a different state. They have a number of family members, an age, a gender, marital status, total income, and travel time to work. As we look at this, we have specific individuals. The individuals within this study come from the 10 randomly selected U.S. residents. So as we look at this, we're going to talk about this a little bit later, but that 10 would be representative of what we call little n. And so little n represents the amount of individuals that come from that specific study. We then go to a second thing. What are variables? Well, within variables, we actually have 7 different variables that are here, okay? Variables are things that we measure. So these are like measurable items. Sometimes these measurable items can come from 2 different things. The first thing that we have is something called categorical. Probably have heard this before in another class. And the second thing we have is what we call quantitative. So quantitative and categorical. Now, it kind of is everything that you probably already know about these 2 different variables. Categorical is something that that we would consider something that doesn't necessarily, that kind of is fit into categories. So things like states, right? So we would have, like, states would be a category. Gender, that's a category, okay? Marital status, definitely a category. And that would be it there. Now, each of the other items, the other variables, could also be fit into categorical. If I said something like those that were from ages 50 to 60. So it's possible that these could be fit into categories. But for the most part, the other ones, we'll put these as red items here. This would be quantitative. So things that can be measured. So these are measurable. A lot of times they are numbers, but like measurable items. Sometimes within these categories, just because they're a number doesn't mean it's a category. Something like a zip code would be more of a category because it's fit within specific groups. So just kind of keep that in the back of your mind that's there. But each of the ones in red within the 10 randomly selected individuals have, again, categorical and quantitative measurements or variables that are here, okay? Another thing we want to look at here is this idea of within categorical variables, again, you know that it fits it within several groups or categories, okay? The way that we label them, we notice, for instance, that we have a different radio stations, right? We have some that are adult contemporary, country, right? That's more my jam. I'm a big country guy. I also like I like some spiritual music. Some of you may prefer other ones, but you'll see that you have a specific count of these stations. So because of the fact that the format of each of the radio stations is specific categories, we call this a categorical variable that's here, okay? Now, something that's important is we have this thing called the distribution. Distribution, what does that mean? Well, a distribution is, it's like the way that we present data, okay? Sometimes we have different distributions, and we'll talk about that as well, okay? But as you notice, we have this frequency table compared with a relative frequency table. Now, how we do this is a frequency is the amount within each station. So we have 1,556 stations. That's related to a frequency, okay? That's the amount. So anytime that I'm talking about amount or count right here, that is a frequency. Whereas over here, a percent, we relate that to a relative frequency. So 11.2% of the radio stations are adult contemporary. You'll notice the news talk, 15.7%, and so on and so forth, okay? That's how we would write that out. Now, within these individuals, again, we would represent the individuals as the different radio stations. So the individuals are the radio stations themselves, right? And the variables is the count whereby they're measured, whether that's as a frequency or as a relative frequency that is there, okay? You kind of see that accordingly, kind of get that down as well. Now, in displaying categorical data, we can display it two different ways. This is very important. So in a categorical data, again, remember categorical meaning that it's split into categories or groups. Within categorical, we can represent this from a bar graph perspective or a pie chart perspective, okay? So I can either take this and make this into a bar graph, traditionally with a frequency table, or I can make it into a pie chart, traditionally a relative frequency table. So a good example of this would be if I were to take a frequency table and transform that here. Let me actually go forward. You'll notice that here would be representative of my relative or my frequency or count here, okay? All right, sorry, we got to get to our next class. JK, sorry, just all right, so the frequency would be more or less the number. So you'll notice contemporary would be just above that 1500 mark, right? Okay, and you'll see that each of these categories are here. And a couple things to note too, bar graph, because there's going to be a difference that's going to be ahead. You'll see the difference here. Bar graph have gaps, and the categories are on the x-axis or what's below. So categories are below. That's a couple things just to note. And then also the fact that it's related to frequency. When we talk about relative frequency, again, percents, right? Relative frequency is in percents. A categorical data is represented by a pie chart. So as I look at adult contemporary, I recognize that that relates to 11% of the radio stations. So a pie chart is something that I can utilize to be able to see the full picture of all of the radio stations and the percents that contribute to each of the categories within each of the types of radio stations that's there. Okay. Now, as we look at this, we have sometimes good and bad ways that we can represent this data. One of the ones that I really wanted to look at is this idea of this DirecTV. Now, I love Dora the Explorer, so I'm going to do it right now. I want you to yell out as loud as you can in your house the answer to this next question. You ready? All right, here we go. The question is, what makes the following DirecTV ad seem like, what's the problem with that specific bar graph? Is there something that you see here that is incorrect or wrong that may throw off the data that's here? I want you to yell out as loud as you can. Go. All right, that's pretty good. I think that's pretty good. When we look at this data, you see the area that's associated with Dish, cable, and DirecTV. And even though over here has 81 and 56, proportionally, you look at 95, and again, this is just a ploy by advertisers. Even though 95 is not that much bigger than 81, if you look at this blue area, you'll notice that the graph is thrown off, or it throws you off by thinking that, wow, DirecTV has so many more channels than Dish and cable, when in reality, it's throwing you off based upon the way the bar graph is set up. So just kind of keep that in the back of your mind in future times, because it can, again, throw you off. That's there, okay? All right, homework, you don't have to do that. We'll come back to those later on. Again, just a heads up, make sure that you continue to follow. This would be more 1.1b. So just, again, a heads up on this one here. Okay. All right. So all right. So a couple things that we want to note here is the two-way table. So we're going to talk about this, and marginal distribution. Okay. Now, when we have two categorical variables, we examine the counts of what's occurring, okay? And we could talk about how we use two-way tables, and we'll actually talk about this more in like chapter 11. But we have this idea called association, where we see if two specific variables are related to each other, okay? That would be what we would be talking about here, okay? So for instance, if we're talking about the young adults and their view on being rich, we could say, is there an association between male and female, or gender, and the perception of whether they can be rich or not within society? All right, that's actually pretty powerful when you talk about perception of male and female, and you could tell a lot of issues regarding what's going on here, okay? All right, and so that's kind of what we would do within that, all right? So once we get it and go from there, we ask the question, what are the variables described by this two-way table, okay? And so as you could see, you notice that the variables would be the male and female, as well as the perception on how they viewed their chance of being rich within the future, okay? Now, how many adults were surveyed? Well, we recognize that the total within each category, well, you'll see that here's the amount of males, females, because that would be the total right here, total of males. And then the total is 4,826. That's the total amount of young adults that were surveyed, okay? But you'll notice, again, a two-way table, it'll describe two categorical variables, and it organizes them into different rows and columns and allows us to compare, was the perception different between males and females on whether they thought that they were rich or not, okay? We're going to look into that. So as you can see here, you'll recognize that you'll see kind of an output here, and we call this a mini tab output. We'll talk more about that later, but you'll definitely be able to see that there's differences here. So as you look at those that said that they were almost certain that they would be rich, you'll see that males had a higher perception on saying that they would be rich compared to females. You'll see the females actually had a higher perception of having almost no chance of being rich, and some chance, but probably not. They had higher probabilities compared to the males, which stated that later on that they would have a better chance of being rich than did females that were there, okay? All right, so let's talk about marginal distribution, all right? Now, as we look at marginal distribution, we relate it to categorical variables in a two-way table of counts, and is the distribution of values of that variable among all individuals described by the tables. We could refer to this as our percents, okay? So a lot of times when I look at this, percents, just like I stated over here, if I gave you a count of 96 and 98, or 486 and 597, a lot of times it's a lot harder to see, and percents are able to share a little bit more of the story than do counts. So we call that marginal distributions, okay? So we use this data in the table to calculate that marginal distribution of both the row or column totals, okay? And then you can make a graph too to display it. So it kind of looks like this. So we take our two-way table, again, two categorical variables, gender and perception on whether they would be rich. And we divide that up by stating what the percents are. So as I look at this, we can recognize that out of all the individuals, excluding males and females, we would say that out of the individuals, 4% stated that they would have almost no chance of being rich. 14.8% said that they had some chance. 29.3% said 50-50, and so on and so forth. So we call this a marginal distribution, where we take the 194, which is the almost no chance row, and we divide it by the total individuals, and we do that for each of them. And that's how we get to our marginal distribution, okay? Marginal distributions, we're able to compare which one out of the individuals that were studied out of the 4,800 students there, what perception or what percent of them, what did they think more or less in terms of their chances of being rich? And then once you notice this, you'll see that this is, again, a bar graph because of the fact that it has gaps in between, and we have categories down below. And what we can do then is on the left side, make sure that we label this by putting percents, and then also that survey response. That's huge for the AP exam. And then being able to then say, okay, this is being able to see the graph by saying, oh, okay, they kind of hung out in the 50-50 in good chance column for what they thought of being rich as. Okay. All right, very good. Now let's talk about our next thing. We call this conditional distributions. Okay, marginal was what we said before, but marginal was more or less what we thought about within the totals. Okay, so notice totals would be more marginal. When we talk about that, though, you'll notice that it doesn't really divide up between males and females. So to make this a little bit clearer, we're going to now go into what we call a conditional distribution. Okay, now this describes the values of that variable among individuals who have specific values of another variable. So instead of doing just simply the total like I did, now we're going to have a condition on it. The condition that we're putting on it is what's in yellow, which is the difference between both male and females, and seeing if those percents make a difference. That's kind of what we saw just a little bit earlier. So in this, we'll again select the row or column that we're specifying, and we use the data to calculate the condition that we're putting on it, again, between males and females. And then what we'll do is we'll compare a bar graph, or sometimes we do a segmented graph to be able to find the difference here. So notice here, we're going to take, in this case, 98 and divide that by my, sorry about that, I circled the wrong one. So 98, divide that by 2,459. And in doing so, we get 4%. We do the same for females. And what we're doing is we're saying what percentage of females said that they had almost no chance of being rich. And then we just went straight down. And what this allows us to do is to find the word again. We talked about it earlier. The association between males and females and their perception on whether they would be rich or not, and their likelihood of being rich. After we put this out there, you could probably compare them pretty easily, but just in case, we can do what we call a segmented bar graph. So this is a segmented bar graph here, where each of the colors correspond to the different category where males and females are aligned separately. So this is still categorical. And then what we do is we have a relative frequency graph because of the fact that it's percentages, where it's a conditional distribution because we placed a condition on the way that we distributed the data between males and between females. So you'll recognize here that the almost certain and good chance, the green and purple, you'll see that males had a higher percent of individuals here compared to females, whereas the females had a higher percent within the lower two categories than did males. Okay? Now, does that paint a picture? Yes, the power of statistics is that it can paint a picture, be able to help you to identify maybe some problems within either society or within the sphere of influence around you, depending upon where I drew that population from. So it's just something to think about there, okay? All right, I'm just making sure. Gotcha, we're good. All right. Again, one thing you can also do is, and I wonder if I've got it here. Yeah, here you go. Here's something else you could do. Over here, we did the segmented bar graph where it's built on top of each other. So again, segmented bar graph, because it's, again, built into segments, one bar within each category, but highlighted or shaded differently. Whereas over here, this is a side-by-side bar graph, where I'm able to compare the males and females. Again, make sure you label that. That's huge. Make sure you label here. Make sure you label here. Make sure you label here to be able to say, okay, the side-by-side bar graph, we're able to kind of compare the different, the condition within each category that's there. Okay. All right. Perfect. Okay, let's keep going. We've got that. We've got that. We're good. All right, we're almost done. I want to get to one more thing. All right, here's again, it's something that can conclude here. If I were to conclude on an AP exam, this would be something that we could say. We could say based on the sample data, and one thing to always mention is context. So what's the context that we're talking about? We're talking about males and females. We're talking about their perception on whether they would be rich or not. So that's a huge thing. Always include context. So when we talk about that, based on the sample data, men seem somewhat more optimistic about their future income than women. It's true. Men were less likely to say that they have some chance, but probably not than women did. And then also notice when I compared that, I put the percentages. That's very important for that there. And men were more likely to say that they have a good chance. Again, we compared it. Or are almost certain, and compared them, to have much more than a middle-class income by age 30 than women were. So again, just an idea. And then the big thing, we say that there's an association between two variables if specific values of one variable tend to occur in common with the specific value of the other. So one variable being males and females, right? Or we could say gender. And the second variable of the other, this other would be perception of being rich. Okay, very good. And that's how we would write it out there. Okay. One other thing, we haven't talked about this yet. Sometimes there are specific things that are kind of lurking. These are variables that are lurking in the background that could have some impact on why specific women responded the way they did. So could it be that women responded more to, they responded higher here compared to here because of the way that the question was worded? Could it be that there was a male that asked this question that kind of allowed the responses to deviate? These are questions to ask in terms of statistics on whether the results can be really valid to conclude what we just stated. And we don't really have enough information within this study to be able to state that, but something to think about as we go forward there, right? This was section 1.1. We will look a little bit further in just a little bit in the second video about inference, the holy grail of statistics. I hope you have a fantastic day and a fantastic summer on video number 1, statistics. See y'all.